let's see what you remember about arc length. So how many radii does it take to get halfway around the circle? Pi. How many do you get all the way around the circle? 2 pi, or tau is what some people use. But I like using pi. And so if you have to do any conversions, there's 180 degrees in a half a circle. What is that for radians? Pi. So you have this conversion of degrees to radians of, just remember there's 180 degrees every pi radians. And you can think of these ratios one of two ways. 180 over pi or pi over 180. That's how you're going to convert, because you're just going to use your knowledge of units. If you have 30 degrees, which makes more sense, 180 over pi or pi over 180? Which doesn't make sense? The first one, 180 over pi, because 180 degrees over pi, you're going to get degrees over radians, makes no sense. But if you do pi over 180, you can see that the degrees kind of cancel out. And so this is going to be pi over 6. So you can convert anytime you want. We'll do that. We'll see why that's important in a bit. So how many radians, how many degrees are there? Wait a minute, hold it. Yeah. So when I look at this ratio, I'm going to look at arc length S and compare it to the arc length all around the circle. So if you have a radius r, what's the arc length going all the way around the circle? 2 pi r, yep, there you go. And in every angle theta, there's a total of 2 pi radians. Do you agree? So if we take this ratio, arc length is to 2 pi r, and compare it to the ratio of theta, see, here's your theta, and compare it to how many thetas in a circle? 2 pi. You can see something kind of cool happening. These 2's and these pi's will cancel, and so you'll get S is equal to theta times r. And this is the equation for arc length. Nope, this is how far S this is. So one more time, I did S is to the distance all the way around the circle, 2 pi r. Theta is to theta, all the thetas around the circle is 2 pi. When you set one ratio equal to another ratio, you get a proportion, and the 2 pi's cancel, giving you S equals r theta.
So if you roll the wheel theta degrees, it would move across around S.
Yep, that's perfect. Yep. The other one we use is going to be a sector. And for a sector, we're going to do the same thing. We're going to say, all right, for the area of a sector, what's the area of a whole circle? The entire circle, what's the area? Pi r squared. And then compare that to theta angle compared to 2 pi. Now when we set this ratio equal to this ratio, it's called a proportion. And then you can cancel out pi's, and notice that area is going to be 1/2, cross multiply there, r squared theta, and that's the area of a sector. One glitch to this, and that is if you put in degrees, you'll get an answer that makes no sense, and it'll be wrong. In higher math, you have to know some things, that degrees are made up by the Greeks. Did we mention that yesterday? Did I mention that yesterday? And that you have to convert to radians in order to get an answer for arc length. Okay? So those are the two formulas, S equals r theta, and A equals 1/2 r squared. If you can't remember them, you can actually prove those real quick. Find the arc length and area of a sector. R is 7 and theta is 40. So S is equal to r theta. The radius is 7 centimeters, and the angle is 40. So if I multiply those out, I just get 280 centimeters. Is that the length of the arc? No, not quite. This is 40 is going to throw us off and give us a wrong answer. You just go 40 over times pi over 180. So these cancel out, and so you're going to get 280 over 180, which is, I think, 14 over 9 centimeters. Isn't that neat? You have to convert to radians or it's not going to work. Area of a sector is 1/2 r squared theta, 1/2, 7 centimeters. You're tempted, oh, it's squared. You're tempted to put in 40, but you're going to have to go 4 pi over 18 or 2 pi over 9. And so that's just going to be 7 pi over 9 centimeters squared. That's the area of a sector. Seem easy? You know why? Because it is. But it comes up in weird ways on the HL exam, and I want to make sure that you've seen some so that they don't catch you by surprise.